Edward Teller was a Hungarian-born American theoretical physicist who is known colloquially as the father of the hydrogen bomb. Although he claimed he did not care for the title, he made numerous contributions to nuclear and molecular physics, spectroscopy and surface physics. His extension of Enrico Fermi's theory of beta decay, in the form of the so-called gamma-Teller transitions, provided an important stepping stone in its application, while the Jahn-Teller effect and the Brunauer-Emmett-Teller theory have retained their original formulation and are still mainstays in physics and chemistry. Teller also made contributions to Thomas Fermi theory, the precursor of density functional theory, a standard modern tool in the quantum mechanical treatment of complex molecules. In 1953, along with Nicholas Metropolis and Marshall Rosenbluth, Teller co-authored a paper which is a standard starting point for the applications of the Monte Carlo method to statistical mechanics. During this time he made a serious push to develop the first fusion-based weapons as well, but these were deferred until after World War II. After his controversial testimony in the security clearance hearing of his former Los Alamos laboratory superior J. Robert Oppenheimer, Teller was ostracized by much of the scientific community. He continued to find support from the U.S. government and military research establishment, particularly for his advocacy for nuclear energy development, a strong nuclear arsenal, and a vigorous nuclear testing program. He was a co-founder of Lawrence Livermore National Laboratory, and was both its director and associate director for many years. In his later years, Teller became especially known for his advocacy of controversial technological solutions to both military and civilian problems, including a plan to excavate an artificial harbor in Alaska using thermonuclear explosive in what was called Project Chariot. He was a vigorous advocate of Ronald Reagan's Strategic Defense Initiative. Throughout his life, Teller was known both for his scientific ability and his difficult interpersonal relations and volatile personality, and is considered one of the inspirations for the character Drive, Strangelove in the 1964 movie of the same name. Early life and work. Teller was born on January 15, 1908, in Budapest, Hungary, into a Jewish family. His parents were Ilona, a pianist, and Max Teller, an attorney. Despite being raised in a Jewish family, he later on became an agnostic. Religion was not an issue in my family, he later wrote. Indeed, it was never discussed. My only religious training came because the Minter required that all students take classes in their respective religions. My family celebrated one holiday, the Day of Atonement, when we all fasted. Yet my father said prayers for his parents on Saturdays and on all the Jewish holidays. The idea of God that I absorbed was that it would be wonderful if he existed. We needed him desperately but had not seen him in many thousands of years. Like Einstein and Feynman, Teller was a late talker. He developed the ability to speak later than most children but became very interested in numbers, and would calculate large numbers in his head for fun. Teller left Hungary in 1926, partly due to the discriminatory numerus clausus rule under Miklos Horthy's regime. The political climate and revolutions in Hungary during his youth instilled a lingering animosity for both communism and fascism in Teller. When he was a young student, his right foot was severed in a streetcar accident in Munich, requiring him to wear a prosthetic foot, and leaving him with a lifelong limp. Werner Heisenberg said that it was the hardiness of Teller's spirit, rather than stoicism, that allowed him to cope so well with the accident. Teller graduated in chemical engineering at the University of Karlsruhe, and received his Ph.D. in physics under Werner Heisenberg at the University of Leipzig. Teller's dissertation dealt with one of the first accurate quantum mechanical treatments of the hydrogen molecular ion. In 1930 he befriended Russian physicists George Gamow and Lev Landau. Teller's lifelong friendship with the Czech physicist George Plaček was also very important for his scientific and philosophical development. It was Placzek who arranged a summer stay in Rome with Enrico Fermi in 1932, thus orienting Teller's scientific career in nuclear physics. In 1930, Teller moved to the University of Göttingen, then one of the world's great centers of physics due to the presence of Max Born and James Franck. But after Adolf Hitler became Chancellor of Germany in January 1933, Germany became unsafe for Jewish people, and he left through the aid of the International Rescue Committee. He went briefly to England, and moved for a year to Copenhagen, where he worked under Niels Bohr. In February 1934, he married his longtime girlfriend Augusta Maria Missa Harkani, the sister of a friend. He returned to England in September 1934. Missa had been a student in Pittsburgh, and wanted to return to the United States. Her chance came in 1935, when, thanks to George Gamow, Teller was invited to the United States to become a professor of physics at George Washington University, where he worked with Gamow until 1941. At George Washington University in 1937, Teller predicted the Jahn-Teller effect, which distorts molecules in certain situations. This affects the chemical reactions of metals, and in particular the coloration of certain metallic dyes. Teller and Hermann Arthur Jahn analyzed it as a piece of purely mathematical physics. In collaboration with Brunauer and Emmett, Teller also made an important contribution to surface physics and chemistry, the so-called Brunauer-Emmett-Teller isotherm. Teller and Missa became naturalized citizens of the United States on March 6, 1941. When World War II began, Teller wanted to contribute to the war effort. On the advice of the well-known Caltech aerodynamicist and fellow Hungarian émigré Theodor von Karman, Teller collaborated with his friend Hans Bethe in developing a theory of shock-wave propagation. In later years, their explanation of the behavior of the gas behind such a wave proved valuable to scientists who were studying missile re-entry. Manhattan Project. Los Alamos Laboratory. In 1942, Teller was invited to be part of Robert Oppenheimer's summer planning seminar at the University of California, Berkeley for the origins of the Manhattan Project, the Allied effort to develop the first nuclear weapons. A few weeks earlier, Teller had been meeting with his friend and colleague Enrico Fermi about the prospects of atomic warfare, and Fermi had nonchalantly suggested that perhaps a weapon based on nuclear fission could be used to set off an even larger nuclear fusion reaction, even though he initially explained to Fermi why he thought the idea would not work. Teller was fascinated by the possibility and was quickly bored with the idea of just an atomic bomb, even though this was not yet anywhere near completion. At the Berkeley session, Teller diverted discussion from the fission weapon to the possibility of a fusion weapon, what he called the super, an early concept of what was later to be known as a hydrogen bomb. Arthur Compton, the chairman of the University of Chicago Physics Department, coordinated the uranium research of Columbia University, Princeton University, the University of Chicago, and the University of California, Berkeley. To remove disagreement and duplication, Compton transferred the scientists to the metallurgical laboratory at Chicago. Teller was left behind at first because while he and Missa were now American citizens, they still had relatives in enemy countries. In early 1943, the Los Alamos Laboratory was established in Los Alamos, New Mexico to design an atomic bomb, with Oppenheimer as its director. Teller moved there in March 1943. Apparently, Teller managed to annoy his neighbors there by playing the piano late in the night. Teller became part of the theoretical division. He was given a secret identity of Ed Tilden. He was irked at being passed over as its head. The job was instead given to Hans Bethe. Oppenheimer had him investigate unusual approaches to building fission weapons, such as autocatalysis. in which the efficiency of the bomb would increase as the nuclear chain reaction progressed, but proved to be impractical. He also investigated using uranium hydride instead of uranium metal, but its efficiency turned out to be negligible or less. He continued to push his ideas for a fusion weapon even though it had been put on a low priority during the war. On a visit to New York, he asked Maria Goppert-Mayer to carry out calculations on the super for him. She confirmed Teller's own results. The super was not going to work. A special group was established under Teller in March 1944 to investigate the mathematics of an implosion-type nuclear weapon. It too ran into difficulties. Because of his interest in the super, Teller did not work as hard on the implosion calculations as Bethe wanted. These two were originally low-priority tasks, but the discovery of spontaneous fission in plutonium by Emilio Segres gave it increased importance. In June 1944, at Bethe's request, Oppenheimer moved Teller out of T Division, and placed him in charge of a special group responsible for the super. Reporting directly to Oppenheimer, he was replaced by Rudolf Peels from the British mission, who in turn brought in Klaus Fuchs, who was later revealed to be a Soviet spy. Teller's supergroup became part of Fermi's F Division when he joined the Los Alamos laboratory in September 1944. It included Stanislaw Ulam, Jane Roberg, Jeffrey Chew, Harold and Mary Argo, and Maria Goppert-Mayer. Teller made valuable contributions to bomb research, especially in the elucidation of the implosion mechanism. He is believed to have been the first to suggest the solid pit design that was eventually successful, a design that, despite becoming known as a Christie pit, after physicist Robert F. Christie, who made the pit a reality, was initially proposed by Teller. Teller was one of the few scientists to actually watch the Trinity nuclear test in July 1945, rather than follow orders to lie on the ground with backs turned. He later said that the atomic flash was as if I had pulled open the curtain in a dark room and broad daylight streamed in. Decision to drop the bombs in the days before and after the first demonstration of a nuclear weapon. The Trinity test in July 1945, his fellow Hungarian Leo Szilard circulated the Szilard petition, which argued that a demonstration to the Japanese of the new weapon should occur prior to actual use on Japan, and with that hopefully the weapons would never be used on people. In response to Szilard's petition, Teller consulted his friend Robert J. Oppenheimer. Teller believed that Oppenheimer was a natural leader and could help him with such a formidable political problem. Oppenheimer reassured Teller that the nation's fate should be left to the sensible politicians in Washington. Bolstered by Oppenheimer's influence, he decided to not sign the petition. Teller therefore penned a letter in response to Szilard that read, "I am not really convinced of your objections. I do not feel that there is any chance to outlaw any one weapon. If we have a slim chance of survival, it lies in the possibility to get rid of wars. The more decisive a weapon is, the more surely it will be used in any real conflict, and no agreements will help. Our only hope is in getting the facts of our results before the people. This might help to convince everybody that the next war would be fatal. For this purpose, actual combat use might even be the best thing." On reflection on this letter years later when he was writing his memoirs, Teller wrote, "First, Szilard was right. As scientists who worked on producing the bomb, we bore a special responsibility. Second, Oppenheimer was right. We did not know enough about the political situation to have a valid opinion. Third, what we should have done but failed to do was to work out the technical changes required for demonstrating the bomb very high over Tokyo and submit that information to President Truman." Unknown to Teller at the time, 4 of his colleagues were solicited by the then-secret May to June 1945 Interim Committee. It is this organization which ultimately decided on how the new weapons should initially be used. The committee's four-member scientific panel was led by Oppenheimer, and concluded immediate military use on Japan was the best option. The opinions of our scientific colleagues on the initial use of these weapons are not unanimous. They range from the proposal of a purely technical demonstration to that of the military application best designed to induce surrender. Others emphasize the opportunity of saving American lives by immediate military use. We find ourselves closer to these latter views. We can propose no technical demonstration likely to bring an end to the war. We see no acceptable alternative to direct military use. Teller later learned of Oppenheimer's solicitation and his role in the interim committee's decision to drop the bombs, having secretly endorsed an immediate military use of the new weapons. This was contrary to the impression that Teller had received when he had personally asked Oppenheimer about the Szilard petition, that the nation's fate should be left to the sensible politicians in Washington. Following Teller's discovery of this, his relationship with his advisor began to deteriorate. In 1990, the historian Barton Bernstein argued that it is an unconvincing claim by Teller that he was a covert dissenter to the use of the weapon. In his 2001 memoirs, Teller claims that he did lobby Oppenheimer, but that Oppenheimer had convinced him that he should take no action and that the scientists should leave military questions in the hands of the military. Teller claims he was not aware that Oppenheimer and other scientists were being consulted as to the actual use of the weapon and implies that Oppenheimer was being hypocritical.